Welcome to Cherry Hill Tuition, where incredible results are achieved. In this mathematics tutorial, I will cover some of the excellent processes used by Cherry Hill to achieve the highest grades. Let's get started. Before we go through the carefully selected questions, let's go over some background theory. So, today's tutorial will be about an equation that we can use in order to work out the Cartesian equation if we have been given the gradient and 1 point on a line. So the equation is y minus y1 is equal to m, which is the gradient, x minus x1. So for example, if we knew that the gradient was 2 and we had which was 2, 1, we can plug these values into the equation and work out the equation of the line. So let me show you how this works. So this will be x1 and y1. So we have y minus y1, which is 1, is equal to m, which is 2, brackets, x minus x1, which is 2. And now we just expand and simplify. So y minus 1 is equal to 2x minus 4. And then we can add 1 to both sides, leaving us with y is equal to 2x minus 3. And that's our Cartesian equation. Again, this will probably make a lot more sense once I start going through some more examples. So let's move on. You will notice that the question numbers are not consecutive and do not start from 1. This is simply because the questions refer to Cherry Hill specific material, but do not worry if you do not have access to this, as I will still cover the concepts in full. So using the following formula, find the equation of the line that passes through the following pairs of points. Okay, so question 3, we have 3, 5, and 1, 2. Okay, so we've been given coordinates, but we don't know what the gradient is. In order to substitute into this and find the equation, we need to work out the gradient. We can do this by using this formula here. So let's label our points. This can be x1, y1, x2, and y2. So the gradient is equal to y2, which is 2, minus y1, which is 5, over x2, which is 1, minus x1, which is 3. And this simplifies to, so 2 minus 5 is minus 3. 1 minus 3 is minus 2. The negatives cancel out, so the gradient is 3 over 2. Okay, so m is equal to 3 over 2. Now, using either this point or this point, we can plug into this formula here and work out the equation of the line. So let's use the second point, 1, 2. So 1, 2, and m is 3 over 2. So y minus y1, which is your y value, which is 2, is equal to m, which is 3 over 2, brackets x minus x1, which is your x value, which is minus 1. And now we just expand and simplify. So y minus 2 is equal to 3 over 2x minus 3 over 2. We can add 2 on both sides to make y on its own, leaving us with y minus 2 plus 2 is equal to 3 over 2x minus 3 over 2 plus 2. On the left-hand side, the minus 2 and plus 2 cancel out, leaving us with y is equal to 3 over 2x. And then we have minus 3 over 2 plus 2, which gives us a half. And this is your equation. Okay? Have a go at this on your own again to see if you get the same answer as me. Question 6, we have 1, 2, and 3, 4. So again, we do the same thing. We work out the gradient first. So y2 is 4 minus y1, which is 2, over x2, which is 3, minus x1, which is 1. This simplifies to 2 over 2, which is 1. So our gradient is 1. So m is equal to 1. And let's use 1, 2 as our coordinates to plug in to find the Cartesian equation of this line. So y minus y1, so let's name this x1 and y1. y1 is 2 is equal to 1, which is your gradient, x minus x1, which is 1. And now we just expand and simplify. So y minus 2 is equal to x minus 1. We can add 2 on both sides, leaving us with y minus 2 plus 2 is equal to x minus 1 plus 2. And the 2's cancel out, leaving us with y is equal to x plus 1. And that's our equation of our line. Okay? So the more you do this and the more you practice this, the easier it will get. So keep trying. And again, I would advise that you try this question on your own again to check if you get the right answer. Let's move on to perpendicular bisectors. Let's say we have a line A to B. A perpendicular bisector to this line will cut this line exactly in the middle and also be at a 90-degree angle to that line. Okay? There is a way to work out the gradient of the perpendicular bisector. Let's say that the gradient of AB is 2. This means that the gradient of, let's name this CD, will be equal to minus 1 over 2. So the way I've done this is I've flipped the gradient of A over B. So AB is currently 2 over 1. I've flipped this and also changed the sign. A way you can remember this is, let's name this M1 and M2. M1 multiplied by M2 has to be equal to minus 1. 2 over 1 multiplied by minus 1 over 2 gives us minus 2 over 2, which is minus 1. So you can either use this, or you can flip the fraction and change the sign. That's how you work out the gradient of the perpendicular bisector. And it always cuts at the midpoint. This will make more sense once we start going through a few questions. So let's get started. Question 13, find the perpendicular bisector of the line joining A and B together. So we've got 2 points. The best thing to do would be to work out the gradient of AB first. The gradient formula is y2 minus y1 over x2 minus x1. Plugging in our numbers, we get, so let's label our coordinates first. y2 is 5 minus y1, which is minus 3, over x2, which is 4, minus x1, which is 1, and this simplifies to 5 plus 3, which is 8 over 3. So our gradient is 8 over 3. Now we can straight away work out the gradient of the perpendicular bisector. We can do this by flipping the fraction. So let's say this is M1. M2 is the perpendicular bisector gradient. We flip the fraction and change the sign. So the gradient is minus 3 over 8. And remember, to check if we're right, both gradients need to multiply together to give us minus 1. So we get minus 24 as our numerator and 24 as our denominator, which gives us minus 1. So we know we are right. Okay, so the gradient of our perpendicular bisector is minus 3 over 8. And the perpendicular bisector always cuts at the middle. right in the middle, in the midpoint. So the next step is to work out the midpoint of A and B. The midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So let's add the x's together. We get 1 plus 4 over 2. And adding the y's together, we get minus 3 plus 5 over 2. And this leaves us with 5 over 2. And minus 3 plus 5 is 2 over 2, which is 5 over 2 and 1. That's our midpoint. Now that we have our midpoint, and remember, in order to use the equation of a line, so let's just make this a little bit more clear. So the midpoint is 2.5 and 1. We can rub this out. Now that we have the midpoint and we also have the gradient of the perpendicular bisector, we can use the formula for an equation of the line, which is y minus y1 is equal to mx minus x1. We can use this to work out the equation of the perpendicular bisector. Now, in order to work out the perpendicular bisector equation using this equation, we need one point on the line, which is the midpoint here, and also the gradient, which we have here. And now we just plug our values in. So y minus y1, which is the y value. So let's 2.5 and 1, x1, y1. So y minus 1 is equal to minus 3 over 8 brackets x minus x1, which is 2.5. So let's just change that back into a fraction. 5 over 2. And now we just expand and simplify. So we get minus 3/8 over x. And then we multiply minus 3 over 8 by minus 5 over 2. We get plus 15 over 16. And then we can add 1 to both sides to get y on its own, leaving us with y minus 1 plus 1 is equal to minus 3/8 over x plus 15 over 16 plus 1. The 1's cancel out on the left-hand side. So on the right-hand side, we have minus 3 over 8x, and then we have 15 over 16 plus 1, which should give us an answer of 31 over 16. And that's your answer. Okay, so it might seem a little bit tricky at first because there are a few steps, but practice will make perfect, so keep trying. And again, have a go at this question on your own to check if you get the right answer. Question 16, find the perpendicular bisector of the line joining A and B together. Okay, so we need to work out two things in order to work out the perpendicular bisector. So we're trying to get to the point where we can use this equation to work out the equation of the perpendicular bisector. To do this, we need the gradient and also a point on the line. As we discussed before, the perpendicular bisector intersects in the midpoint of AB. So what we can do is work out the midpoint of AB, and that will give us a coordinate on the perpendicular bisector. So the midpoint is x1 plus x2 over 2, and then y1 plus y2 over 2. And now we just plug our values in. So we add the x's together, 1 plus 3 over 2, and we add the y's together, minus 6 plus 1 over 2. And this gives us 1 plus 3, which is 4, divided by 2 is 2. Minus 6 plus 1 is minus 5, and then we have minus 5 over 2. So that's a point on our perpendicular bisector. And now we need the gradient of the perpendicular bisector. So the gradient of the perpendicular bisector we can work out by working out the gradient of AB and then working further. So gradient of AB can be worked out by using y2 minus y1 over x2 minus x1. So it's 1 minus 6 over 3 minus 1, and this leaves us with 7 over 2. Okay, so this is M1. M2, which is the gradient of the perpendicular bisector, we flip the fraction and we change the sign. And remember, M1 multiplied by M2 should be equal to minus 1, so we need to check this. 7 over 2 multiplied by minus 2 over 7 does give us minus 1. Okay? So we've worked out the gradient, it's minus 2 over 7. And we also have a coordinate of point lying on the perpendicular bisector. And now using this equation, we can work out our equation of the perpendicular bisector. So this is x1 and this is y1. So y minus 5 over 2 is equal to minus 2 over 7 brackets x minus 2. And now we just expand and simplify. So y plus 5 over 2 is equal to minus 2 over 7x. And then we multiply minus 2 over 7 by minus 2, which gives us plus 4 over 7. We can minus 5 over 2 on both sides. On the left-hand side, the 5 over 2 cancels out, leaving us with y. And on the right-hand side, we are left with minus 2 over 7x. And then we have 4 over 7 minus 5 over 2, which gives us an answer of minus 27 over 14. And that's our answer. So again, this might seem a little bit tricky at first, but the more you do, the more questions you do on this, the easier it will get. So pause this video now and have a go at this on your own to check if you get the right answer. Thank you for tuning in. Remember, practice makes perfect. Never give up. I will see you in the next tutorial.